a side and included angle. We'll use it in a second. The second one, so we used this in geometry. I don't know if you remember using this in geometry because it kind of looks like 1/2 base times height, doesn't it? It actually comes from that formula. It's just that you have to use the sine of an angle to find the height, essentially. The second one we never learn in geometry, and I don't know if that has changed. It's called Heron's formula. Have you heard of it? It's not the bird, but there is a bird, but they're not related. If you want to try to make something up where that helps you remember it, all right. So here's how it works, and I'll tell you what these things are in a second. In Heron's formula, what we do is we take something called the semi-perimeter of a triangle. How do you think you would find the semi-perimeter of a triangle?
Perimeter and half.
Half of the perimeter, okay? And so what we do then is we take the semi-perimeter, which I'll call S, and I'll label what these things are in a second. And you take S and you multiply by that semi-perimeter and the difference of that in all of its sides. So we do S minus A times S minus B times S minus C. Okay. So we're going to, A, B, and C are the sides of the triangle up here. S is equal to A plus B plus C divided by 2. Semi-perimeter. Okay. So I'm going to do one example using law of cosines, and then I'm going to do one example involving the sassafras. Sassy, I don't know what you want to call it. And then the last one is Heron. Okay, so let's see here. I have this handy little template thing. You don't have that. There we go, we'll use this one. Alright. Would you draw a baseball diamond, please? Would you draw a baseball diamond? Which is just a square. Okay? So it says, let's label some things. The bases on a baseball diamond are 90 feet apart. So, let's see, baseball players. What's this? Home plate. This would be first base, and what this is saying is it's 90 feet. 90 feet. Okay. And let's just assume that the tenders of the field are true geometry students, and they are sure that it's a square. Okay? They've got their protractor out and made sure it's the right angle. All right. So I'm just going to point out to you. Hold on a second. Where's my calculator? It's saying that the center of the pitcher's mound is 60.5 feet away. I'm going to just point out to you that that is not exactly halfway between home and second. Okay. And so let's just try to find this by using Pythagorean theorem. 90 squared plus 90 squared equals 16,200. Okay, so I'm just verifying for you, so you believe me, that the distance from here to here, I just used Pythagorean theorem, is 127.279 feet. If I divided that by 2, it's 63 to the halfway point. What I'm saying is the pitcher's mound is only 60.5. I'm only saying that so you understand that this is not going to form a right triangle that I'm going to need to use law of cosine. So I'm going to put the pitcher's mound right here, and I'm going to make sure I make it so it's not halfway. It's a little before halfway. And I'm going to draw a line from the back of home plate to the middle of the pitcher's mound, or whatever, and I'm going to make sure that I understand that this is not going to be a 45-degree angle. And this is 60.5. Find the distance from the center of the pitcher's mound to the far corner of first base. So I'm going to draw that. And this angle is not a 90-degree angle. Okay. Nope. But that's why I purposely drew it a little less than halfway, because we just showed by using Pythagorean theorem, 60.5 is not halfway from here to here. But I want to find that distance, so I'm going to call that x. So what things do we know? Well, we know that this is 90. We know that this is 60.5. And I do know this, that the pitcher's mound should be perfectly aligned with home plate. So I should know that even though this isn't 90, this angle right here is going to be 45 degrees. Now, I'm just going to point out to you, because there's a lot going on in this picture, let's look at this highlighted triangle. What things do I have? Okay, I can use law of cosines when I do side angle side. Okay, so as long as the side opposite the angle, remember, has to go on the left side of the law of cosines. So I would write x squared equals, what are my other two sides? 90 squared plus 60.5 squared minus 2 times 90 times 60.5 times cos of 45. Would you guys get your calculators out for me, please? What do we get? 63.717. Okay. Now, I don't know that if that's true or not. No, this would be true given the situation. I don't know that in a high school field that the pitcher's mound to the center is at 60.5 feet away. Because you know how different fields are different sizes, like in Little League, aren't they?
Yeah.
Yeah. So maybe when baseball season starts, you can bring your tape measure out and check our math work. Okay. Questions on that so far? So now I'm kind of weird about drawing perfect shapes, so I'm going to use my little template. If you want to share these and draw an octagon because you're weird too, that's fine. I'll put them up here. It used to be that everybody got one of these little things. Remember Okay, we're going to draw an octagon, please. And it doesn't have to be perfect. A regular octagon. What does the word regular mean from geometry?
All the sides.
All sides and what else? Good, okay. So, it says, now we're going to have to do our best because I don't have compasses. It says, find the area of a regular octagon inscribed inside a circle. What does that mean?
Oh my gosh, with all the corners touching the circle.
Yeah, it means, and inscribed means it's inside the circle. So I'm going to try to draw a circle around it where it touches all the sides. Okay, so that's not too bad. If you want to draw the circle, then just put 8 points around the circle and connect them. If you already drew the circle first. That works too. Oh, and all I did is I just really carefully drew a circle around it. Alright, so here's how we're going to use side angle, side area formula. If it's a regular octagon, it has 8 sides, right? What we're going to do is I'm going to go here and draw one of the given things in the problem, which is a radius of 9. And if the radius is 9, then it's going to go to also one of the vertice points. You see that? I'm going to draw one of the triangles formed in this. By the way, what's this piece right here then? Would you agree with me? I'm going to just do them dotted. How many of these triangles could be in here?
1, 2, 3, 4, 8.
Right. Do the triangles all look congruent to one another? Yeah. So give me a strategy then. If I wanted to find the area of the regular octagon, what could I do? Find one of the triangles and then multiply it by 8. Okay. Now here's the problem. Unfortunately, this isn't 9, so I can't use the Heron's formula. But I do know something about all of these angles at this point. They add up to 360. So let's divide 360 by 8. And what do we get? 45, right? Alright guys, so what do I have? I have a side, angle, side. So what area formula can I use? Side, angle, side. Alright, how am I going to do it? The area of the one triangle is 1/2 the side times the side times the sine of the included angle. So I'm going to write 1/2, 9 times 9. Now, if I wanted to do this exact, what is the sine of 45? We know it. √2/2, okay? But I'm going to use my calculator and then I'm going to multiply the whole thing by 8 because I want the area of the octagon. By the way, 8 times 1/2 times 9 times 9 is the same as 4 times 9 times 9. So, and then the units would be, did you get the same thing? Uh-oh. Okay. You got what? What happened to me? Oh! I went back to radian mode. Whoopsies.
I got 229.
Yep. And this would be square centimeters or centimeters square. Alrighty, finally. Are you with me? Am I going too fast? Okay. The last thing I'm going to do is I'm going to use Heron's formula. Heron's formula you are going to want to use when you have 3 sides. So the first thing I need to do is find the semi-perimeter. So and guys, I'm going to just have a little rant here. I'm getting tired of looking at silly, I won't say stupid, calculator mistakes. Like people who will type this just in their calculator like that and be like, oh, and then they'll get the answer wrong. You can't just type that in your calculator. You have to use a parentheses or do it in your head. Because otherwise, your calculator will only divide the last thing by 2. And does this say to just divide 12 by 2? No! It doesn't. It says to divide the whole thing by 2, right? Alright, so 5 plus 10 is? 15 plus 12 is? 27 divided by 2 is? 13.5. Okay, so here's how Heron's formula works. You have 4 numbers in there. One is s. We just found that. The other one is the difference between s and every of the sides, every one of the sides. Put that wrong. So I need to find s minus a. So what's 13.5 minus 5? 8.5. So we have 13.5. Now here's the deal, guys. To be quite honest, you should just put this in here. We should be able to do that in our heads. But I'll write it down just so you don't forget later on how I found it. S minus a is, we'll call this A, B, and C, is going to be 8.5, right? What's S minus B going to be? 3.5. Is this too much thinking? Alright, so I'm going to do 13.5 times 8.5 times 3.5 times 1.5 and take the square root. You know what you could also do? If you forgot, you could do law of cosines and find an angle and then use side angle phi. It's a lot more work. But if you get stuck,
Is it 24.54?
it is.
Ooh, got it, Joey.
And this would be centimeters squared again.